Hello, today we're going to be talking about memory maps. Memory maps are crucial for understanding virtual memory and file input output in Linux. A memory map allows programmers to control the logical address space of their process to map to physical memory elements of their file system in Linux. We discussed the concept of logical address space. This is essential to memory management in operating systems. The logical address space separates the view of memory by each user process from the physical memory, simplifying memory management in a process and enhancing security. We look into the mmap system call, which is central to memory mapping in operating systems. The system call allows us to map files into memory. We look into parameters like start, length, prot, flags, and fd, and how they're used to create this mapping. Uh, Before mapping files into memory, certain preparations are necessary. The use of the system call fstat is helped to determine the size of the file and preparing destination's file space in memory to avoid errors. Let's go ahead and switch gears and look into how this function works. I have a code written over here, and we're going to look at how this works. So first, we open a file called example.txt. We open the file, and then inside the file, we first get the size of the file. We throw an error if the size is 0 or the file does not exist. We ensure that the file is not empty. If the file is empty, we close our file function. Next is our mmap function, where we map our memory from, we take the contents of the file and then we map it into our memory. We use the flags prot read, and map is set to private. And then we also have an error, which if the mapping fails, it throws an error and it closes. We read from the mapped memory, which is not necessary, but just to show it to you guys. And then before we exit, we clean our memory map, and then we exit. Uh, let's go ahead and look into how this function works. So let's go ahead and look into GDB to see if the memory gets mapped into our process's logical address space. So we're going to set a breakpoint before our memory map line, and then we're going to look at the memory for our process before, and then we're going to look at the memory process after. So let's go ahead and run it. We run and we reach our line where the mmap happens. So according to GDB, this line's not run yet. So we go ahead and do xnc, and then we looked at what is an mmap file. Essentially, it says that you cannot access the memory at address 0x0 because that does not exist. But when we hit next, it firstly it's gonna throw an error. It's gonna check if the mapping fails, but after that, it essentially reads from the file and then puts it into memory. So our example.txt just contains 3000 A's. So essentially, let's go ahead and run our xnc command to look at the memory. So essentially, it just prints out a bunch of A's, and it's gonna keep doing this. So I'm gonna press continue, and essentially, this is our print function working, and it essentially prints out the 3000 A's. And now the process has exited. So if we essentially did this, there's no map file in current context. So essentially, map file was deleted. And that's how memory mapping works. Thanks for listening to me, and have a great day.